will start this today's LeetCode problem. This is LeetCode medium. This is given a smallest string starting from leaf. We have given the root of a binary tree where each node has a value in the range 0 to 25, representing the letters A to Z. We have to return the lexicographically smallest string that starts at the leaf of this node and ends at the root. As a reminder, any shorter prefix of a string is lexicographically smaller. For example, AB is lexicographically smaller than AB. Okay. So in this, we have to find the lexicographically smallest string, which starts from leaf and ends with root, not from root to leaf, right? So we need to make a string which from leaf to its root value, and we need to return its lexicographically smallest string, right? So, and what will the lexicographically smallest string? It means if suppose there is given D A C B and something is given D D B C B A. So the first one is lexicographically smallest because it is declared at the position third, which is A and C. So A is less than C. But what if this A and B is given? Then lexicographically smallest will be DBAB, not DBABA, because it is ended first. So the second part DBAB is the smallest string, right? So this means the lexicographically smallest string, right? So we need to find the lexicographically smallest string in this whole tree from leaf to root. So here we have given the root value, which is 0, 1, 2, 3, 4, and which is corresponding to the letters A to Z value, right? So how do we solve this question? So for this, what we can do? So okay, uh, if I see a constraint here, then the number of nodes is given is only 8500, right? So 8500, it means it is something 10 to the power 3, right? So yeah, 10 to the power 3, right? So 10 to the power 3, it means I can, if I take if I take Z here, right? Let's take an example. Uh, yeah, let's make a tree over here. So Z B. So we can do this both in uh, iterative and recursive approach, right? So this is given B Z. So now if you see, this is given B, and this is C, and this is okay. So this is A and this is C, right? So if you see, what I can do is just make this large. See, if I start from Z, right? If I start from Z, Z, B, D, and C. Let's zoom it. Oh, sorry. So if I start from Z, I will I will move to this Z. I will, what I will do, I will make this string. I will insert this character in my string. I will take a string variable and I will insert this string in my answer Z. Okay. Suppose I move to D part, then I also insert this character in my Z. Now if I move to this left or right, suppose I move to right, it becomes JDC. And suppose so this C is a leaf node, so I will, what I will do, I need to see this string is minimum or not. But before that, this is from root to leaf, and we need to find from leaf to root. So I need to reverse it value. So what I will do, if this temp is JDC, I will reverse this and make this as CDZ. And now I will compare from my, I will compare it from my final answer string, that which is small, and I will simply update it. I will simply update it. So this is a simple kind of recursion approach, that we will move to every part of node. Means I will move to its left also, I will move to its right also, and whenever I hit a leaf node, I will update my final string, which is the minimum, by reversing it, because we need to find from leaf to root. So we at the end we will get the string from root to leaf, but by reversing we will get from root to leaf to root, right? So again, this C is JDC. So my answer is JDC for now. Now when I backtrack this, I will pop back this C is JDC. When I will move to this T, I will pop back my C here to ZD. Now this A becomes what this A becomes. This A will become ZDA. Now again, this is a leaf node, so I need to compare this with this JDC. So JDC and JDA, which is smaller, of course JDA is smaller, so we will update this to JDA, right? Now again, for this value, from here I will start. So here it's ZB, right? We will move back to this D. Now move back to Z. Now we will iterate in left. This is ZB. Now again this ZB is again here, so it's again ZBB, right? Now B is a leaf node. B is a leaf node here. Now we will compare this answer, which is ZDA now, and we will compare from this ZDB. So what will be the, okay, this is given, okay, yeah. So what will the answer? ZBB, because this is a lexicographically smallest from ZDA. So the final answer will be my ZBB. So my final answer will be ZBB. So if you see, okay, sorry. No, my final answer not be ZBB. I forgot to reverse every time I got to the lift. So when we come to JDC, this is stored CDZ, right? Because I need to reverse my final string, right? Whenever I go to answer, whenever I got leaf node, I will reverse my temp, right? Forward to, and then I will compare this, right? Temp, and then I will compare, which is small. So the for when I come to C, it becomes CDZ. Now when I come to ZDA, it becomes, I will compare from ADZ to CDZ. So ADZ is smaller. So this ADZ. Now this ZBB. So I will reverse this ZBB. So I will compare from BBZ to this ADZ value. So this becomes BBZ. Right. So this will not change any answer in my answer. So answer will be ADZ only. So this is my answer, right? So yeah. So how, this is how can I do this? So let's run. So if first, what will I check? The first condition, I will maintain a string and a final string, right? Second, I will move to every node, either in left and right, and update my temp string along that, and when I get a leaf node, what will I do? I will update. I will reverse first. I will reverse my temp string because I need to because uh, I need to I need to make a string from leaf to root, right? And then I will compare it with my final string, right? And I will also backtrack. I will also backtrack. So for this, I need to because I have reversed this temp string, so I need to reverse it back. So for I will also backtrack. For this, I need to reverse this string again, temp string again, right? And also whenever the recursion ends, I will and when recursion ends, when a function ends, sorry, when a function call ends, I will also remove the last character of temp string with then so that I can when this JDC comes here, when I backtrack this, then it becomes JD, then I insert this A, then it becomes JDA, right? If I don't backtrack this, then it's becomes JDCA. Understood? So this will be the steps. Let's follow this, right? So if my root is not, then I will return string. Okay, now I will make a final answer here, which is takes to be a string. Now I will call this root and this as a temp value. So this string should be temp. Now what I will do, I will call this a root value and this string. I will pass this as a by reference, not by value, because if you the difference between the pass by reference and pass by value is, if you pass by value, it makes another copy of that strings, which takes a lot of time. But if you pass by reference, it will just point to its existing memory, and it will not, and it will also update accordingly. But if you pass a value, it will pass the copy of that, right? So that will take a more of time of complexity, right? Because every time you make a copy, and you every time iterate in whole of length, right? So now what we will do, I will push back this root value plus a. So what will this do? This root value is suppose this is 0 and this is a, so it becomes a. So this is to convert from mapping to characters, right? So now I will move to its left, and I will also pass this temp, and also I will move to its right. I will pass this temp. Okay, so what will the condition? The first condition is if the root is null. If root is null, I will simply return because I can't do anything. But if the root is a leaf node, if the root is leaf node, so what is the leaf node condition? That it has no children. So left part is null and right part is also null. So if this is a leaf node, the first thing I need to do is I need to push back this root ka value, the current root, which is the leaf node, and I need to reverse it to make it what to make it. I need to reverse it because I need to make string from left to root, because for now this is root to leaf, but I need to make it from left to root. And now I will compare with my answer whether if the answer is empty string, means this is the first leaf node, so I will make this 10. Otherwise I will take the minimum of answer comma temp, right? So this is how I will, because this answer is, if answer is empty, which means this is the first value, and after that I will store the minimum of both. Now I need to also reverse back this temp, right? Why? Because if I don't reverse it, it will becomes ADZ, not ZA, right? So I need to reverse back it, and also I need to pop back it and return. This pop back is for backtracking, right? Backtrack. Okay, I also need to, I have push back here, so I need to also pop back from here for backtrack, right? So, and at last I will return answer as my final string. So let's see what's the answer. So yeah, we have passed the cases. Let's submit it. Yeah. So what will the time complexity for this? So if you analyze the time complexity, we analyze the time complexity for this. So this will be O of n, because I need to move it at every nodes, plus for I'm also passing a string in this, and also reversing for every leaf node, right? So I'm only reversing for every leaf node. So at most position, so at the maximum of the total of how much maximum a leaf node can be. So it depends on number of nodes, so that will not be much because this is only 8500. So either it can be one, or it can be some another part. So for that calculation, this is not compulsory, but it will not be much, it will not create much effect, right? So basically you can take O of n, because let's suppose there is a chain of strings, and at last I need to reverse it. So it can, you can take, this is O of n roughly, right? So O of n for O of 2n for reversing string, because I need to reverse it twice. So and O of n for this recursion stack. So basically it becomes O of n actually, right? This becomes O of n actually, and the space complexity will be, so I am taking one is as a final string answer, and also one as a temp to storing that. So that will be in worst case O of n. And what is n here? N is number of nodes in tree, right? So this will be the time complexity, space complexity. So can we reduce it? So if you use BFS instead of this DFS iterative way, so you can reduce this remove this recursion stack value, and that will be again O of n. So if an interview, if they told you to use BFS, so because they, some interviewers don't want recursion stack, right? And also you also need to always try iterative way. So okay, let's see how much time is left. 9:44. Okay, let's see iterative way also, right? Right. Let's see iterative way again. So what will we do in iterative way? I will use a BFS, and I will again, I need to make a queue here, and what I will do, I will simply insert a root tree node with a string, and I will push this as a pair. This should be inserted as a pair, and this should be the root, and this will be the string part, root value plus this character, because I need to string typecast this. This is a character, and this can be this is used to typecast this, right? So now I need to iterate in this queue. I will iterate in this queue, and this will be the first node, and this will be the string. So what will I do? I will just use this same function. If my node value is uh, node value is leaf node, then I will insert like this. So first I will check for this value. If my node value, if my node left is, if this is a leaf node, just I'm checking if this is a leaf. If this is a leaf node, what will I will do? I will update the same condition if my answer is empty. If my answer is empty, I will insert this as a temp. Otherwise, I will insert as take as a minimum. Right. So I don't need to pop back or something because I'm inserting a string with its root every time. So at every root there will be a string value in this function. Right. So also I need to reverse this first, and I will need to backtrack this. So what will I do is I need to reverse this first, then again I have to reverse it back. This should be 10, right? So I need to reverse this and reverse it back. Otherwise, if this is not a deep node, then I will check whether its left node is exist or not, and I will insert its node left value and this string with the current string with uh, this. Okay, you can insert like this also. 10 dot pushback this node left plus this a, right? So I can insert like this. Same for right value. If my right is exist, then I will insert my right value and insert it my q. So this will be the same, and if this is not, then I will reverse it. So let's see. Okay, let's see what is this node and temp for me. So let's node this left. This is node right. Let's run this. ZB ZBD. How this is coming ZBD? How? Oh, okay, right, right. Okay. The problem is here. The problem is here. When I'm inserting temp dot pushback here, so I'm also inserting temp dot pushback here. This is the same string which I'm pushing, so that's why the this is happening. So instead of this, what I can do is I can simply like this temp. Instead of this using temp, I can insert this temp plus left value plus a. I can write like this character, right? Same goes for this. Instead of pushing, I can use this. Okay, and I will reverse this again and I will install this. Let's see. Okay, this should be right. Yeah, we have passed the case. So if you can see, if you can see here, the thing is, if you can see, instead of pushing like this and going to reverse like this, if I insert it like this character at first value and this is at last value, so it will reverse it in, it will reverse in, it will insert this in reverse order, right? So in when I go to leaf node, I don't need to reverse it value, right? I don't need to reverse it again. So this will work also fine because it will store in my as in reverse fashion, because I first insert character then I will add time. So this will work also fine. So this is how I can solve this as iterative and recursive approach both. So the now time complexity will be the same, but we have removed the extra recursion stack space. That is good, right? Thank you.